On the graphing review worksheet, several of you asked about problems 6, 7, 8, and 9, so I'll go through those with you. So we want to think in terms of transformations of parent graphs. So the parent graph here is just the graph of y equals x squared. So that's just a standard parabola that goes through 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4, if we went over one more, 3, 9, and negative 3, 9. And so that parent graph goes through those points, and we'll consider these as our 3 anchor points for now, maybe 5 anchor points. We'll see which ones still come into play. So the transformations that have happened is we've replaced x with x plus 4, so that's going to shift it to the left 4, and the negative 1/4 in front is going to be a vertical flip. The negative makes it a vertical flip, and the 1/4 is a vertical compression. Okay, and so the point 0, 0 is going to move. Well, let's do the vertical compression first. We should always do the vertical stretch and compression first. So this point that was at 1, 4, its y value is going to now be multiplied by negative 1/4. So that's going to put us down here at negative 1. If we had graphed the point on the original graph 4, 16, now it would be 1/4 of that, so it would be 4, negative 4. And so we can use those as our anchor points, and so we only have the point at 0, 0 stays where it is, and so we would also have negative 4, 4. And so you see the graph has gotten a lot shorter and shorter than the original graph because of the vertical compression, and it's also flipped. Now we just need to move that graph to the left 4. And so 1, 2, 3, 4. This point 1, 2, 3, 4. This point 1, 2, 3, 4. And 1, 2, 3, 4. And 1, 2, 3, 4. Okay, so now our final graph looks like this, going through those 5 anchor points. Problem number 7 is very similar. We're going to start with our parent graph of y equals x squared. Okay, and now what's going to happen, we've got 3 things happening to this transformation. The plus 4 is going to move it left 4. The minus 5 is going to move it down 5. And then the minus in front is going to be a vertical flip. Okay, so let's do the vertical flip first. So these points are now down here. So there's the vertical flip. You always do the vertical stretch and compressions first, and then now we're ready to shift left 4 and down 5. So all 5 of those anchor points are going to go left 4 and down 5. So 1, 2, 3, 4, 1, 2, 3, 4, 5. So this point moved down here. Okay, and then the point at negative 1, negative 1 is going to go left 1, 2, 3, 4, down 1, 2, 3, 4, 5. The point at 1, 1 is going to move here, and the other points will be off our screen. And so there's our final graph. Number 8 is an exponential graph with a vertical stretch of 3. And so to graph, first let's graph our parent graph y equals 2 to the x. And so if we plug in some values, just to refresh your memory on this, I'm pretty sure you graphed this in Algebra 1, but probably need a refresher. So let's do -2, -1, 0, 1, 2, 3. And so let's start with 0. 2 to the 0 is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth power is 16. 2 to the negative first power, that's 1 over 2. Remember, when you have a negative exponent, that means you move it to the denominator or to the opposite position. So that's going to be the point -1, 1/2. 2 to the negative second is 1 over 2 squared, which is 1/4. And so if we go to -2, 1/4, that's going to be really small. -2, 1/2, or sorry, -1, 1/2, 0, 1, 1, 2, 2, 4, 3, 8, and 4, 16. Okay, so there's our parent function. That's just y equals 2 to the x. Now we're going to multiply all the y values by 3. This is a vertical stretch of 3. And so this point, which was at first point, which was at a height of 1/4, is now going to be at a height of 3/4. This one was at a height of, we're at 0, 1, so multiply by 3 and you get 0, 3. 1, 2 becomes 1, 6 when we multiply the y value by 3. 2, 4 becomes 2, 12. And 3, 8 would become 3, 24, which would be off of our graph. So our new and final graph looks like this. Problem 9 is very similar. We just want to think about the graph of the parent function y equals 1/2 to the x power. And so if we make a quick table of values, we'll do -2, -1, 0, 1, 2, and so 1/2 to the negative second power is the same as the reciprocal to the positive second power, which will just be 4. 1/2 to the negative first power is the reciprocal to the positive first power, which is 2. 1/2 to the 0 power is 1. 1/2 to the first power is 1/2, and 1/2 to the second power is 1/4. And so if we plot those values, we have -2, 4, -1, 2, 0, 1, 1, 1/2, 2, 1/4, and so on. And we could even go further if we went to -4. 1/2 to the negative fourth power would be 2 over 1 to the positive fourth power, which is 16. So -4 is going to be up here at 16. And so there's our parent function. So that's y equals 1/2 to the x. And now the 2 in front, all that's going to do is vertically stretch it by 2. So that means we can take the y values of all of these points and double them. And so if I take this point here and double the y value, it moves to 8. If I take this point and double the y value, it goes to 4. If I take this point and double the y value, it goes to 2. 1/2 goes to the 1. 1/4 goes to 1/2, and so on. And so our final graph then looks like this.